Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the discussion on example 4.11, and in this video we are going to continue with the idea of concavity and points of inflection. As we have done the local maximum and minimum point, this has already been discussed in the previous video. So in this video we will be looking at these two parts here, and these two rely on the idea of second derivative, and the second derivative has already been obtained in the previous video, which is this one. Okay, so now I'm just going to write down again the result of the second derivative, which is just 12x times x minus 2. Now based on this, if I set the second derivative equals to 0, so f double prime x is equal to 0, therefore this expression here is 12x x minus 2 equals to 0, and we have two scenarios to consider. The first one is 12x equal to 0 and x minus 2 equals to 0. Because of that, we can say that x must be equal to 0 or x must be equal to 2. So next what we are going to do is we are going to construct the intervals based on these 2 points that we obtained. So this one and this one. So we're going to construct the interval in order to determine the concavity of the graph. Okay, so interval. So for x less than 0, we will be interested to find what is the behavior for x less than 0, and then x between 0 and 2, and finally x greater than 2. And we are going to study the behavior of the second derivative. So here we have the first factor, which is 12x, and then we have the second factor, which is x minus 2. Okay, so multiplying these two factors will give you the sign of the second derivative, and based on that we can determine the concavity of the original graph, which is fx. Okay, if x is less than 0, x takes negative value, therefore this one is going to be negative, and this one is also going to be negative. Negative times negative is positive, and according to the concavity test, this is this results in fx being concave upward. Okay, so let's revisit what you have seen in the previous video. Concavity test, this one. Okay, so if the second derivative of x is greater than 0, therefore fx is concave upward, and if it is less than 0, it is concave downward. So greater than 0 means it has a positive sign, less than 0 it means it has a negative result. Okay, positive and negative value. So back to this table that we have here. Since this is going to be negative value, this is also negative value, then the result is going to be positive value. Therefore, the graph of fx is concave upward. For this one, x between 0 and 2, for example, you can take x equals to 1. 12x is going to be positive. This one is going to be negative. Therefore, positive times negative, because this factor is multiplied with this factor, then the result is going to be negative. So therefore, in this scenario, in this situation, fx is concave, the concavity of fx is this is going to be downward. Okay, this is downward concavity. And then for x greater than 2, this is going to be positive. This is going to be positive. Positive times positive is positive. So it's going to be concave upward. Okay, so this is upward concavity. All right. Now, based on this, we can determine that for point x equals to 0, it is a point of inflection, or this is inflection point, because the concavity of fx changes from upward to downward. So because of that, for x less than 0 and x greater than 0, so you can imagine this is point 0. So for x less than 0, it is concave upward. For x greater than 0, it is concave downward. Therefore, since there is a change of concavity, point x equals to 0 is the inflection point. This is according to what you have seen on this slide here. Okay, it is called an inflection point if the curve changes from either concave upward to downward or concave downward to concave upward. Okay, now in a similar manner, you can see that for x equals to 2, okay, so for x equals to 2, you can see that for x being less than 2, it is concave downward, so this is downward. And then after that, for x greater than 2, it is concave upward. So there's a change of concavity, and therefore x equals to 2 is also the point of inflection. Okay, now based on all this that we have gained, we have obtained the knowledge of concavity and points of inflection. Now it is the time to use all this information to sketch the curve. Okay, so first of all, we're going to list down the important points. So the first point is local minimum. Local minimum is at point x equals to 3. So when x is equal to 3, I need to know what is the value of y, because I need to sketch y onto the graph. So when x is equal to 3, substitute 3 into x here, and you will be able to get that the answer is going to be negative 27. So local minimum s is at the point 3 and negative 27. Next, we have other important points that you need to consider, which is the point of inflection here. So points of inflection. So first, when x is equal to 0, so when x is equal to 0, when you substitute into this function, the answer is going to be 0. And the other point of inflection is when x equals to 2. So when x equals to 2, substitute into this function, and you will get that the answer is going to be negative 16. Okay, so these 3 points are the important points, and we are going to now sketch the graph. Okay. Let's say this is my vertical axis. This is fx, and this could be my x, Okay, so now I can see that I only need to have point 0 up to point 3 for x-axis. So maybe this is 1, 2, 3, 4, 5. Maybe I can stop there. So 0, this is 1, 2, 3, 4, and 5. Next, I can see this is such a huge negative number. So negative 27, negative 16. So maybe I can take that to be negative 5, negative 10, negative 15, negative 20. Or maybe I can make it even bigger, the scale. Okay, let me just erase that. Okay. This could be negative 5. This could be negative 10. Oh, this is really bad. Okay, let me just erase that. Okay, negative 5. Maybe here is negative 10. This could be negative 15, negative 20, negative 25 maybe. Okay, so next what we have is plotting. We need to plot the points of interest. 0, 0 is easy, so at this point, and then we also have point 2, negative 16, so maybe 2, be somewhere here, 16. Next, we have point 3, negative 27. Be somewhere here. Okay, negative 27. Okay, I'm sure you can do better, with proper scale. Okay, but I'm sure you get the idea. Never mind, we're just going to move on. Okay, right. Now, next. When you sketch the graph, first of all, we need to find out what's the behavior of our curve for point 0 until negative infinity. It's from 0 to negative infinity. According to this table, it is decreasing. Okay, but decreasing can be in this manner, or it can also be like this. So which way are we talking about? Is it this one decreasing in this manner, or is it decreasing in this manner? Now the first one here is related to, oops, oh, what's going on? Oh, I don't know what's going on. Hang on. Okay, so the first one here, if I sketch one, I choose one point here and I draw the tangent, you can see that this is the graph that is above the tangent. So this is concave upward. And again, if I draw this point here, I know the tangent is somewhere here. So this graph here is below the tangent line. So this is concave downward. So although it is decreasing, we need to understand whether it's decreasing this way or in that way. Now, that's when we refer to the next table that we have already constructed here. So this is concave upward for x less than 0, which means for the interval between negative infinity and 0. So it is concave upward, which means in this manner. Okay, so we're going to draw the curve. So it's going to be something like this. Concave, upward, decreasing in nature. Okay, right. Next, for the next one is for x between 0 and 3, it is also decreasing, but we need to find out whether it's the concavity is upward or downward. So between 0 and 2, it is concave, the concavity is downward. So this is at point 2. So between 0 and 2, the behavior of it is concave downward. It is decreasing. So now from this one is from 0 to 3, but we're going to consider it's decreasing in the manner of concave downward until 2. So concave downward means it's going like this. So it is going like this. Let me just erase the curve first. Okay, so again, so it is something like this, and since this is the inflection point and it's concave downward. This is really bad. Give me a second. Okay, so first of all, from negative infinity to 0, it is decreasing, concave upward, so it's going to be something like this. Yep. Now, since 0 is an inflection point here, we know that it doesn't change because the graph is going to continue decreasing, but the concavity of fx is going to be downward. So downward means it's going to be like this. So maybe like this. This is really bad. Okay. Something like this. I think this should be alright. Okay, so something like that. Next, just give me a second to get it really right. Okay, so this is concave downward. Okay, I hope you can see why this is concave downward and this is concave upward. Now after x greater than 2, concavity of fx is upward. Okay, but then it is still decreasing. Okay, it is still decreasing until 3, because according to this one, it is still decreasing until 3, but the concavity is upward from this point until infinity. So what does it mean? So it means that it's going to change, the concavity is going to change from downward to upward, so it's going to be like this, similar to the first graph here, upward. So it's going to be like this. Concavity is upward and it is decreasing, and after 2 is also going to be concave upward, but you can see from this part here, when x is greater than 3, it is increasing. So when after x greater than 3, which means this is at the lowest point now. So this is at 3. Now it's going to decrease, but it's going to increase, and the concavity is going to be upward, so it's going to look like this. Okay, so basically that's the idea, or that's how the graph can be sketched. Okay, so I'm just going to label it. So this one is decreasing and concave upward, decreasing. For this part here, this is decreasing and concave downward. Okay, for this part. Okay, this is decreasing and concave upward. Next, for this one is decreasing. This is decreasing, concave upward, and after that this is increasing and concave upward as well. So the idea of this combination that you have seen on this graph comes directly from consideration of this table and the table constructed on this page. Alright, I hope you guys get some idea on this, and maybe if you want, you can try to sketch the graph of this function here on your own, and maybe later on I will upload the video related to this example. Alright, thank you very much for watching. I'll see you in the next video.